and Bill Holiday Award. Without further ado, I'd like to turn it over to Ken. Thanks, Ken.
Well, thank you for that introduction. I'd like to start today. I mean, 2020 has been quite the year, and I know, besides us dealing with the pandemic, we have now the wildfires on the West Coast, which is dealing with a lot of issues. Seems like someone needs to move in the background. There we go. We have now the wildfires that we're dealing with. So some of the things we're going to be talking about is going to be interesting because we want to use some more outside air when the outside air conditions aren't going to be very viable with these wildfires. It does cause us problems, and we'll talk a little bit about that today. But I'd like to start first by thanking the ASHRAE volunteers, including your new officers and the Board of Governors. Becoming involved with ASHRAE really provides us with a single resource for keeping up with technical advances in our industry. Not only does ASHRAE allow us to gain direct access to new technology and universally recognized technical information, but it also allows us to really influence the direction of the built environment. And there's several hundred ASHRAE volunteers that have been active since the beginning of this pandemic that have been providing guidance and continually updating that guidance on building operations. And I'm going to focus a lot on some of that today, but we're also going to talk about just what we know about COVID-19 and SARS-CoV-2. So let me get started here. The agenda today, I'm going to talk a little bit about what we know about the virus, what we know about the transmission of the virus. We'll get into HVAC systems and COVID-19. I'm going to talk about some of the known, what I call community spread events that have occurred and been well documented and researched and studied, and what we've learned from some of that. I'm going to get into ASHRAE's COVID-19 guidance. I'm going to focus on non-healthcare facilities. Healthcare facilities is a little bit different, and so, I mean, there is guidance on that, and most healthcare facility guidance really follows our ASHRAE standards for healthcare facilities. It's not special in this case, but it is special for a lot of the buildings that we're reoccupying, and that's what I'm going to focus on a lot today. And then I'm going to give you some concluding remarks and leave some time for question and answer and discussion, because this is something I think we all want to be talking about. And even if a lot of you have been following the guidance as it initially came out in the spring, it's changed a lot since the initial guidance in the spring. And it's changing throughout the world. It's not just ASHRAE, but it's also CIBC, ACAR, some of the other organizations that are in other parts of the world that are also coordinating with ASHRAE, trying to get consistent recommendations out there. So first about COVID-19 and SARS-CoV-2. Most of you probably realize this, but COVID-19 is a disease, and SARS-CoV-2 is the virus that causes the disease. Just so we're on the same page in terms of terms when we start talking about this. As far as the transmission routes, the coronavirus particle is extremely small. You see here it's 80 to 160 nanometers. And from the CDC, almost most what they believe is the primary means of contact is through droplets. And that means when someone expels droplets, you see here the middle item where the droplets come out. Those droplets are usually, they're greater than 5 microns in density, and someone could be talking, they could be singing, they could be yelling, they could be coughing, they could be sneezing, but it's those droplets that then we inhale, or they go onto a fomite surface, which is a secondary way that we can do this. And most droplets, because of gravity, will tend to fall out within 6 feet. Indirect contact is when those droplets end up landing on contaminant surfaces, and then we call them fomites. And that's when we touch those surfaces, and we might touch our eyes, or we might touch our mouth or our nose, and that's how we can actually transfer the virus to ourselves from the fomites. And then lastly is aerosols, and aerosols are considered to be less than 5 microns in diameter, and these are light enough that they can be suspended in air for longer periods of time. And definitely go over long distances. When we talk about long distances, it can go for tens of meters inside a space in aerosol form. And I'll talk a lot more about aerosols as we get into this. I would like to at least talk about the hierarchy of controls. And this is from NIOSH, and they have a hierarchy of controls. And this was before even COVID-19 came out. But it really talks about where you want to put your effort. Elimination is obviously the #1 thing, and that's why it's the largest part of the pyramid. In elimination, in this case, if we're talking about trying to eliminate the exposure of multiple people in buildings, is that we make everyone work remote and they don't actually go to the building, and that's an elimination strategy. A substitution really doesn't apply that I know in this case, but when we get to engineering controls would be HVAC mitigation strategies in the building. That's an engineering control. When we get to administrative controls, examples would be social distancing, cleaning and disinfecting, reducing cross-contamination, and even capacity guidelines in terms of how many people we're going to be putting in the building would be administration. And then the last thing there is PPE. And the reason why PPE is lowest on the list is because it's hard to control every individual to follow those type of guidelines. We can say that we're going to require face mask in a facility, but some people might not wear the face mask when they get up from their desk and they go to the restroom or they do something. And so that's why it's the last. So this is just hierarchy of controls, kind of important to remember. So the primary mitigation for SARS-CoV-2 really is have people work remote if possible. For most, so if there's not a necessary reason why they need to be working together, make them work remote or have some people work remote where we can at least reduce the density of people in the spaces. Maintaining the social distancing of at least 6 feet is important. I'd like to say a little bit about face mask. I mean, it can reduce droplet transmission where more than one person gathers. I know ANSAR, which is, they do 3D computational fluid dynamic analysis. And if you go to their website, got a really good video showing people wearing face masks and coughing versus people not wearing face masks and coughing and what it'll do. I mean, the face mask doesn't get everything, but it certainly limits the distance by which people will expel droplets and aerosol if the face mask is worn and they happen to be coughing. So putting it in perspective here, I gave you a single breath does between 50 and 5,000 droplets. Single cough is 3,000 droplets at roughly 50 miles per hour. And when someone sneezes, we're talking about 10 times that amount, 30,000 droplets at roughly 200 miles per hour. So just putting it in perspective, why people sneezing in a space and not covering their mouth is definitely a concern. And then people with symptoms or known to be exposed should stay home. But I put down there in red that it's, you know, a recent study of one of the cruise ships showed that 81% of the people who tested positive were asymptomatic. So if you're just relying on taking someone's temperature and verifying that they don't have a fever, a whole lot of people can be asymptomatic and be spreading this virus. So other things that I think are important that we at least start before we get into recommendations is what's unknown or incompletely known today regarding this, because this is new. You know, we're only in this since March of this year in the United States. Some say February and some of the initial contractions on the West Coast, but it hasn't been very long, and it takes us a long time to actually study this and do some of the research that we really need to know. So one of the things is we really don't know the source strength and infective dose of SARS-CoV-2, meaning how many virons does it really take for most people to get infected. So it limits our ability to make quantifiable control requirements or define conditions or assess the risk. The other thing is survival time of the SARS-CoV-2 in the environment. We've done studies in labs that have said how long the virus stays viable on certain surfaces, but we don't really know exactly what it is, even if it's floating around in the air, how long it's viable. So it can be floating around in the air and become unviable and still end up in filters, and we'll talk a little bit about that on some of the studies that have recently come out. So this really affects some of the decisions about measures to reoccupy the buildings. And then we don't really know the ability of SARS-CoV-2 to transmit through HVAC systems. We definitely know that HVAC systems can have an impact within a space of transmitting SARS-CoV-2, but we don't know a whole lot about its ability to get through the HVAC system and back into another space. And that's something I'll talk a lot about in this presentation. The other thing that's incompletely known is the role of ambient particulate matter on SARS-CoV-2 or COVID-19 transmission. So when we talk about dust particles or other things it wants to attach to and then get onto, what is that role of that particulate matter and transmitting it? And then all of this is kind of, we need to figure some of these things out to figure out what investments in protection now are really going to meet the objectives of mitigate the transmission and provide good benefits to the owners post-pandemic. without compromising energy and environmental goals. We already are going to be doing some compromise on some of those energy and environmental goals. So let's talk a little bit, switch here and go into a little bit about HVAC and COVID-19. So infections occur when a susceptible person receives a sufficient dose of virons. Now, there's some things that come out from some of the different health departments in large counties. County of LA, I think, indicates that they believe that you almost have to be talking to someone without a face mask for roughly 20 minutes to get the quantity of sufficient dose of virons. Now, whether they have any good research beyond those recommendations, their recommendation is that you don't have to notify someone that you've come in contact unless they've been in front of them for 20 minutes and having a conversation with them if someone does actually contract it. So that, I mean, there is this idea that just passing someone walking on a walkway or on a sidewalk and they breathe out and you breathe in probably is not going to be a sufficient dose of virons in order to get it. But again, some of these things are still unknown. We haven't been able to define it, and we might not be able to define it for several years. There's going to be a lot of research beyond this. I mean, even when we ran into SARS-1, it took many years to figure out some of what we needed to figure out. But with SARS-1, we did figure out that it did transmit through the air. I mean, that was one of the things ultimately that we did figure out. So chances are that SARS-2 does transmit through the air is fairly probable. The World Health Organization, the Centers for Disease Control, and other health authorities believe that transmission of COVID is mainly by short range and droplet mode, as I indicated earlier. And some of the community spread or super spreading events suggest the possibility for airborne or aerosol transmission under some circumstances. It's definitely been documented in healthcare environments, especially when they're having to put respirators in on people, that we are getting aerosol. It certainly seems to be documented in some of these other cases that I'll talk about on an upcoming slide here. It is also kind of important to acknowledge that last month, the WHO recently acknowledged that short-range aerosol transmission, particularly in specific indoor locations and inadequately ventilated spaces over a prolonged period of time with infected persons, can't be ruled out. And, that was important. There was a bunch of scientists that ended up writing a combined letter and sent it into the World Health Organization. And after they sent that, it's saying that they really should acknowledge that aerosol transmission is one of the paths by which people can be infected. And it was after that they changed that on their website. There was a recent study that showed the presence of SARS-CoV-2 RNA present in approximately 25% of the air filter samples taken from multiple air handling systems at a hospital. Those droplets were actually collected from the Oregon Health and Science University Hospital in Portland. It is important to point out that the air handlers had both pre-filters MERV 10 and final filters MERV 15, and they not only found the RNA in the pre-filters and the final filters, but they found RNA downstream of the final filters on the supplier dampers. So, chances are, I mean, when someone like I look at something like that, it probably was, and they found a fair amount of samples on the downstream of the filter. So there was a good chance that they probably did not have good seals on their final filters for that to occur. It's just something they didn't point that out in the research article. They didn't even point out whether they looked at what the sealing on the filters was. But when you start to see that kind of thing, you start to think, okay, well, someone should have actually looked at see if the filters were sealed. So I think it is important to point out that there is a risk of HVAC airborne aerosol transmission, and it can be reduced by reducing the airborne concentration. So ventilation, air management, filtration, and air cleaning all would apply in helping to do that. So I have some samples here. So, I mean, poorly ventilated spaces have been cited as primary concerns in the following community spread events. First, there was a restaurant in Guangzhou, China. There were 9 of the 73 people in the restaurant that were infected. If you look at the diagram here on the right, index patient right here, A1, was sitting at this table in the middle. There were multiple zones. This was a wall-mounted fan coil unit that was serving this zone that's shaded. right here. There was actually 4 other zones in the restaurant. The whole restaurant was open to each other. It wasn't divided. And the only people that were infected were in this HVAC zone. One person came in at that table and ended up infecting 9 other people. And so there's a couple very detailed studies. One was done by Lee and another related study by Liu demonstrated how a single asymptomatic carrier, because they didn't actually have any symptoms, infected others outside the typical 6-foot social distancing range. The infected person sat at a table, had dinner with 9 friends. Their meal and those of the diners at the adjacent tables took about only 1 to 1.5 hours. So they weren't in there for a really long time. As I said, the carrier was asymptomatic, but apparently and was not coughing. So coughing was not an issue where we talk about coughing or sneezing. But the release of the droplets and aerosols occurs just simply from breathing. And even if they're in a restaurant, they could have been talking loudly, and that's going to cause more transmission. So the lighter droplets and the aerosols were apparently distributed within the north side of the restaurant by the ductless fan coil unit. And 4 of the people at the infected table became sick in the next 7 days. 3 people at the adjacent downwind table from the HVAC unit became infected, and 2 people from the upwind table were infected. Now, you know, you say downwind and upwind, but remember we have supply air blowing across this, and the returner has to go back the other direction. It's also worth pointing out when they did the study that the ventilation rate in the space was approximately, so the outside air ventilation rate was approximately 1.6 CFM per person. So, you know, we're talking like 10% of what we would normally ventilate in an area. So this was a poorly ventilated space. And it did, it's worth pointing out that only people infected were in this zone. It did not go to the other zones inside the restaurant. So that was worth pointing out. There was a conference center in China where 15 of the 30 people went in for a 4-hour conference. 15 of the 30 people were infected. Only 1 person had the virus ahead of time that they could determine. And what they did determine, though, in that 4-hour period, the HVAC system only ran for 15 minutes. So when the HVAC system only runs for 15 minutes, there is no ventilation, and you have the potential for possible transmission in the space. And that's probably another sign that there could have been aerosol transmission without proper ventilation. And then, obviously, most of you are all familiar with the Puget Valley Chorale rehearsal, where 53 of the 61 people were infected. It's not really documented whether the HVAC unit only ran when the thermostat needed heating, but it was on a night when it was, I believe it was 45 degrees outside. The doors were closed. I know that they did indicate that they turned on the HVAC unit prior to the practice in order to preheat the space. And they didn't know later on whether that was due to that, but you know, definitely it has been documented that when people sing, there's a lot more potential transmission of droplets and aerosol coming out of their throats, the same as yelling or other things like that. So, but that's a pretty significant community transfer event that we saw there. So now I'm going to dive into ASHRAE's recommendations, and I'm going to start a little bit by at least talking about ASHRAE's position document and their position statement. So, you know, it's not easy for ASHRAE to take positions without going to the board. It has to be approved by the board, and these are positions that the board has approved coming up through Tech Council and the task force and our environmental health and committee. So transmission of SARS-CoV-2 through the air is sufficiently likely that airborne exposure to the virus should be controlled. So changes to building operations, including the operation of heating, ventilating, and air conditioning systems, can reduce airborne exposures. That's our official position. Ventilation and filtration provided by HVAC systems can reduce the airborne concentration of SARS-CoV-2 and thus the risk of transmission through the air. And definitely they're recommending that unconditioned spaces can cause thermal stress to people that may be directly life-threatening and may also lower the resistance to infection. In general, we are not recommending disabling HVAC systems as a measure to reduce the transmission of the virus. So it might seem obvious to all of you, but believe me, I have ran into clients where they thought most of the people on their university campus were off the campus. They might have only had a dozen people coming into some buildings, but for energy purposes, they shut off the HVAC systems in those buildings. And that was an absolute no-no. So they definitely need to be running those systems when anyone's in the buildings. So one of the things that ASHRAE really centers their recommendations around is getting together a building readiness plan. So, you know, for people who haven't occupied or they're getting ready to occupy or go back to school or you know, start having classes at the university levels, they're recommending people put together building readiness plans. And it's really something to put together the mitigation strategies that everyone can be on the same page on what that plan is. And this includes not only HVAC related strategies, but non-HVAC related strategies. And I've listed there on the bottom of the slide, the non-HVAC related strategies. But we want it to be kind of comprehensive. We don't want HVAC related strategies not to be considering with the non-HVAC related strategies, because it do go kind of hand in hand with each other on a complete building readiness plan. Some of the HVAC strategies, and we'll get into this in the slides following this, improve filtration, increase the ventilation, air cleaning devices. Each HVAC system has to be analyzed for the appropriate engineering controls to utilize to improve the potential to reduce the virus transmission in the building. And owners really should consider evaluating their building systems to check they're operating properly. So that kind of gets me into this inspection and maintenance mitigation strategy, which is kind of really important. I mean, a lot of us, you know, deal in facilities where some facility operators have good budgets. They tend to maintain things, keep them in tip-top shape. And then we deal with other facilities where they have, you know, a lot of deferred maintenance. There's not a lot of money to go out there and assess what the condition of systems are. But now is the time where we really need to be assessing what the condition of these systems are. If we're serious about going in and reoccupying buildings, we need to know what exactly we're dealing with. Do we have a building where someone has manually gone in and closed the minimum outside air damper because it has a hard time keeping up on the really cold days or the really hot days? You know, what is the condition of the system? Because we want to ensure that the system is operating as it was intended to operate originally before we put people back in the buildings under this pandemic condition. And ASHRAE Standard 180 is a good reference for getting some of the information on what kind of inspection and maintenance to do on those type of systems. And I think it is also worth pointing out that ASHRAE is recommending to consider PPE for building operators when they're maintaining ventilation materials, including filters. And, you know, as we said, there's been no study that I've seen yet that have found live virus on filters, but chances are if we found the dead virus RNA on filters, there probably is a potential for contamination. So we just want to be cautious, and people should be wearing PPE when they're actually pulling the filters out and changing them. So another mitigation strategy is ventilation. And, you know, a good supply of outside air in accordance with ASHRAE Standard 62.1 to dilute the indoor contaminants is a first line of defense against aerosol transmission. Now, those of you that have been following the recommendations of the Epidemic Task Force would realize that when they first came out, and I want to say for the first couple months, they said, go to 100% outside air and run it 24/7. And a lot of us in the industry pushed back to the task force and said, wait, that doesn't seem logical. Where are you getting the basis to go to 100% outside air? And when I talked to Bill Bonflitz, he indicated that they kind of probably jumped the gun and they were following the CIBC guidance, the Charter Institute of Building Services, and REVA, which is the organization in Europe, who originally came out with 100% outside air. And because when you start to think about outside air and you start to think about filtration, the two kind of go a little bit hand in hand. You don't increase filtration and increase outside air. They're kind of two different type of strategies that you can actually take. So one of the things that for any dilution to occur, some of the virus containing particles have to leave the room, either via the return grill or exfiltration through the cracks in the envelope. We know droplets are too heavy for this to occur. So ventilation really is not effective in mitigating that mode of transmission. And there's some good research by Azimi and Stevens that showed that 100% outside air has a similar reduction to viral infections as utilizing MERV 13 filters. So, I mean, when we start looking at these different type of strategies, it's not like throw everything to what, you know, don't put our foot in the accelerator all the way down. I mean, let's look at what strategies really make the most sense. And as I said before, we don't have any events that we can really point to that were super spreader events inside facilities where they actually did have ASHRAE standard 62.1 ventilation rates, ensuring that they were doing that. It's all cases where we had poor ventilation, poor outside air ventilation. So they have backed this down now to make sure that you're in accordance with standard 62.1. Now, there's some other things like definitely considering the pre-occupancy purge with outside air. They are actually asking for pre-occupancy and post-occupancy purges. And I'm probably one to say I'm not really sure I buy why we need to do the post-occupancy purge. And we can talk about that in the discussion if someone disagrees with me. But if the building shuts down, if I do my pre-occupancy purge, I'm going to purge out any type of aerosol contaminants that's going to be in the building. And to do that, that's typically requiring 3 air changes of outside air to reduce the contamination level to 95% if we consider a well-mixed space. And then a last strategy here for when it gets to ventilation is also disable demand control ventilation. And that's pretty easy by just changing the set point on the ppm for the CO2 sensors. But at least during the pandemic, they're saying, why use that energy saving strategy? Let's go ahead and make sure we're providing good, adequate ventilation to get any aerosol out of the spaces. So I'm going to switch to filtration. And filtration is something that I think is good in many aspects. So the recommendations from ASHRAE is use a minimum MERV 13 filter if it does not adversely impact the system operation. We've looked at a lot of different building systems, and certainly there are some systems where we cannot get to MERV 13. You can't get to MERV 13 on a VRF unit that's hung on the wall. You can't get to MERV 13 on existing systems that have 1-inch filters. There are 1-inch MERV 13 filters out there, but I'll let you know that they're all rated at 300 feet per minute. Chances are, if you're converting a system that has 1-inch filters, it was probably rated at 500 feet per minute, maybe with a MERV 8 filter. So when you put a MERV 13 filter in at 300, that's rated at 300 feet per minute, the pressure drop's going to be way too excessive, and it's not really going to work in that type of situation. So there's a lot of things to be considering when you do this. The other thing that we want to consider is we need to make sure that the edges of the filters are sealed to limit bypass. So that's easy to do when we have filters gaskets and we have front load filters. Not so easy to do when we have slide-in filters. And what some of our clients have been doing is they've been taping the filter frames together as they slide them in to try and limit the amount of bypass if they're dealing with slide-in filters that might be in the 2-inch capacity. So, I mean, we have to get creative in some of these because bypass can be a big issue. I mean, if we go and put a MERV 13 filter in and we have a lot of bypass, the aerosol will be able to make its way around the filter. They also are indicating to consider portable HEPA air cleaners if MERV 13 filters can't be used or if there's no mechanical ventilation. That would be something that's inside the space. And then also to open windows where appropriate during occupied hours. And certainly opening the windows is going to be something that is going to depend on what the possible contaminants are outside. Right now in our smoky areas, that's probably not a recommended strategy at this point. We also want to make sure that we don't have toilet exhaust or something right next to the windows that could cause re-entrainment back through those windows. It's worth me pointing out when we talk about, MERV 13 filters, well, what does it really do? And, I have table 12.1, a clip of the table, I guess. I didn't show MERV 1 through 7 in that table just so you guys could read it. But it shows the different ranges by which we rate our MERV filters. And there's different particle sizes. So we have 0.3 to 1 micron, 1 to 3 microns, and 3 to 10 microns. And as you see here, why MERV 13? Well, when you start talking about 0.3 to 1 micron, you really don't get any good filtration on, well, you don't even have to rate the filter when it's a MERV 8 or MERV 9 or MERV 10. But, it's going to be at least 50% good at reducing 0.3 to 1 micron, and it's going to be 85% at 1 to 3 micron. So, I mean, it's trying to get to that level where our PM 2.5 particles get reduced. Now, wildfire situations that are going on right now, what we found out in California, we had the wildfires over the last few years because we've been looking at this on a lot of facilities that have been impacted by wildfires, that we need a minimum MERV 15 filter in a wildfire in order to keep a building occupied. And in some cases, we need to actually have the ability to be changing out those filters in some cases every week. But these are the type of things that we want to not look at just for this pandemic, but let's look at it for, when we have wildfire situations, other things that come up. What's the capabilities, especially if we're going to be designing new air handling systems, and maybe we want to put in a little bit of extra static pressure capacity and the ability that someone could swap out the filters if they needed to go to a higher MERV rate or under special circumstances. I mentioned the research from Azimi and Stevens that was done back in 2013. In that research, they actually were studying MERV 13 filters, and MERV 13, as I said, MERV 13 filters had about the same ability as going to 100% outside air in reducing infectious airborne disease transmission by roughly 31 to 47%. So they were dealing primarily with influenza in that study. This was before SARS, but it's a similar type thing. We can dilute, we can filter. Both are going to have similar type reduction capacities. If you can go higher than MERV 13, obviously you can see on this chart here that you're going to do a little bit better when you do this. So that moves me to unitary fans. So we want to be a little bit concerned about what's happening in the space. I'd say primarily concerned by what's happening in the space, because most transmission of the virus will occur within a occupied space. It's not going to occur from one occupied space to another occupied space in most circumstances. It's going to occur within the space. So ceiling fans blowing down, probably not a good idea. ASHRAE is recommending that they reverse the flow and blow upward to minimize the velocity inside the room. When it comes to pedestal fans or horizontal fans, we really have to be aware of not blowing across someone's face onto others, even if they're wearing a face mask. This is a bad thing that can cause transmission within the space. So when we talk about people wanting to bring in their own unitary little air cleaners on their desk and they want to put it in front of them and blow clean air on them, that might not be a good idea in some cases, unless they're in a room all by themselves. If that's going to blow across their face and blow onto someone else, that's not an effective way of maintaining good control over everyone. And if there is good ventilation air and good filtration efficiency and poor mixing, they're recommending run the fans to get the good mixing. And if fans are the only HVAC in the room, then consider a portable air cleaner with HEPA filter units, or avoid using the room. Exhaust systems, they are recommending the garage exhaust systems run 30 minutes before occupancy. It's preferred to run garage exhaust systems continuously during occupied hours. So if we have any type of demand control ventilation with carbon monoxide sensors, we might want to disable that while we're at least going through the pandemic. Other exhaust systems should continue to run as normally planned, and then run those systems in that pre-purge cycle also. And if there's any exhaust air outlets located in pedestrian areas outside, or like I said, if there's any possibility for re-entrainment, those are things we want to be looking at in buildings to make sure that we're not getting a potential re-entrainment, especially from toilet exhaust. Since we know that the virus is present in fecal matter, and that has been documented as coming out of the toilet when it flushes. So these are things we all want to be aware of on ways that it can be transmitted. If we're dealing with energy recovery devices, most of the time we're going to be okay, but they're always worth looking at. There's a potential for cross-contamination between the intake and exhaust systems on these type of systems. Some ERV units or sections are designed to allow for as much as 5 to 10% being passed into the supply airflow, usually referred to as the exhaust air transfer rate, or EATR, of the ERV. This is really within the ventilation standard allowances and most energy efficient for some spaces and building types. So if it's that, it's good, but it's still worth looking at the ERV and making sure there's not something that's gone wrong with the ERV and could be causing more cross-contamination. I do get a lot of questions on UVGI. ASHRAE does have a position to at least consider UVC light as an enhancement. Where spaces require additional measures. If you can't get MERV 13 filters or 100% outside air is not possible, it's something to be looked at. The effectiveness of UVGI light really depends on the length of time of the microorganism is exposed to the UV, as well as the intensity and wavelength. And so it is interesting to point out that if we're talking about, there's a lot of applications for UVGI. It's not just in HVAC systems. You can go into a room and disinfect it with portable units. We have a university client that goes into their locker rooms that's used by their sports teams in between every time the locker room is occupied, runs the UVGI system, brings it in, disinfects everything in the system, and then allows them to come back into the locker room. But when we talk about duct disinfection, it really requires high doses of UV to inactivate the microorganism as they fly or pass through the irradiated zone. And the issue really is limited exposure time. So, you know, some of the recommendations, there's like 4 primary recommendations when you get into this, but the minimum target UV dose is going to be 1,500 microwatts seconds per centimeter squared. And we're really talking about systems where we can have less than or equal to 500 feet per minute moving in the airstream. So putting it in a duct where it's running at 1,200 feet per minute, not a real practical application. It's moving too fast. The minimum irradiant zone is going to be 2 feet, and the minimum exposure time is normally 0.25 seconds. So you just got to keep these things in mind if you're going to think about putting UVC or trying to do a UVGI type system. And the last recommendation I'm going to give you is building automation and control, which is maintain your dry bulb temperatures within the ASHRAE standard 55 comfort ranges. If you're maintaining relative humidity, if you do have humidifiers in a building, maintain the relative humidity between 40 and 60%. The main reason is because it can reduce the half-life decay time of the virus. The secondary reason is when we have humidity above 40%, our throats tend to be more moist and we're less susceptible to getting the virus contaminating us. We have a more robust system in our body to fight that. You want to automate the epidemic mode operation control sequences, so things that we've talked about like disabling demand control ventilation, if you're going to increase your outside air, anything like that's going to be epidemic mode. We want to program that so it can be turned on and then shut off when the epidemic's over and get things back to normal. And then certainly, you know, we want to use our HVAC control systems to monitor and trend the HVAC measures. So if we can, you know, be trending the outside air quantities, if we can be trending the filter pressure drops, I mean, anything that makes sense for us to trend, the temperature and humidity in the space, the time that we turn on the building, what the conditions are outside. I mean, any of that stuff is always going to be good because when we do have an event in the building, we might want to go back and look and see what the conditions were when that event occurred. So as far as concluding remarks, I mean, I've thrown a lot of stuff at you, but you know, no one or series of measures in a building can guarantee that we're not going to spread the SARS-CoV-2 virus to others when there's more than one person in the building. The only way we can do that is through that elimination on the NIOSH pyramid that we talked about. So there's always going to be a risk of transmission when allowing multiple people to reoccupy a building. Recommendations from many of the high-level organizations around the world, including ASHRAE, as I indicated earlier, have not been consistent and are changing. So they're subject to change. And I think, you know, so if you read it 3 months ago, we might want to go back and reread some of these things because it is changing as we're starting to get more information. The subject is really rapidly evolving as the efforts to control the pandemic continue. And there is no known instance that I am aware of COVID-19 infection from one room to another through a central HVAC system that has been documented in a research paper. Now, it's going to be extremely difficult to prove that when it does occur. There's a lot of cases where people get COVID and they don't know how they got it, but it's going to be difficult to prove. But there's certainly enough knowledge out there that it's not yet definitive, but it could be spread through HVAC systems. And certainly some of the things like finding the SARS RNA virus on the filters, things like that. I mean, there's a definite possibility of aerosol transmission, and we should be cautious about that. research really is urgently needed to identify and implement, I think, some cost-effective measures to operate buildings during the pandemic. And we're going to learn a lot about this. I mean, we're putting a lot of effort and a lot of volunteer resources and money into helping study this. So we might not know it until after the pandemic's over, but we will know it eventually. We're not going to give up on this. Some of the critical questions, that could be addressed by epidemiological studies would include, like, what do infection patterns suggest with respect to the significance of airborne and fecal transmission as a cause of the infection? How does ventilation, air distribution, and humidity affect infection rates? Can we put a direct relationship on the infection rates? And how effective are the various filtration and air disinfection measures in reducing exposures? Some of those things we really want to answer as we move forward, and we're working towards that. The final thing is, as I said, prepare a building readiness plan, ensure building systems are operating as intended. Social distancing and face mask really should help, so that they should be required when reoccupying the buildings. The MERV 13 and 14 filters will help in reducing transmission, and that's been shown in other studies. The HVAC system outside air pre-purge can help, and we should be considering local air cleaners if we can't get the MERV 13 or proper ventilation provided to the space. And that concludes my presentation. I'd be happy to open it up to questions.
Thanks, Kent. I'm going to start off by reading a few of the questions that came into the chat, and then as we get through those, if you want to keep asking questions through chat, or you want to, maybe after we get these answered, we'll have people just unmute and just talk. So the first one here from Austin B. in Rushing, he has a little bit more of a comment, but we'll see if he has anything to follow up with that. ASHRAE has shown through several studies that this virus can infect significantly farther than 6 feet. Some studies show 14 to 30 feet. Review recent ASHRAE journal for specific examples and studies. It's an important fact about this virus. Did you have anything you wanted to follow up with that, Austin from Rushing Co? You want to unmute yourself if you want to have anything else. Okay. Anything, Kent, you want to follow up with that? I think you mentioned.
Well,
that.
no, I think he's done a good job of documenting. I think he might be referring to the HVAC and COVID-19 article that came out in the September journal, which is a good article to read. But I think we don't want to be confused. ASHRAE has shown through several studies that the virus can transmit and go much farther than 6 feet. There's no question about that. About whether someone can be infected and get enough viral loading has not been really documented well. And so, even as I stated, when someone actually coughs, not even a sneeze, if someone coughs, we know that plume goes out almost 6 meters. The 6 feet is not even anywhere close. So 6 feet is a normal thing when someone's actually talking, but it definitely goes way out there farther. As far as aerosol transmission, we know that aerosol transmission, as I said, came for tens of meters and just continue to stay suspended for hours inside a space. The question is that how much of that aerosol virons do I need to get before I become infected? And so what we don't know in the industry right now is what it takes to get the infection itself.
Great. That's an interesting. I'm going to follow up on that. So, viral loading is not something. I've done a lot of healthcare design myself, and infectious isolation rooms. That's not a term that I was really thrown around much beforehand. Was that something that you had heard of before this pandemic?
Yeah, when you go back to some of the studies that were done back even in 2013, or even the studies that were done with SARS-1, they talked about viron loading, which is it's how much you actually have to take in. How much of these particles do you need to take into your throat in order to actually get contaminated? I mean, one particle won't usually be one virus won't be enough to contaminate you in most cases.
All right. So I think you may have covered this after this question, but we'll real quickly. He's asking. This is from Spence Breeden. Can single pass UVC ultraviolet sterilization systems be considered an elimination strategy in regard to the response pyramid?
No, they can't. Definitely would be considered an engineering control strategy. NIOSH, but not an elimination strategy. And we talk about single pass UVC. I mean, when I was on the UVC slide, I focused more a little bit about the induct UVC because we're talking to HVAC engineers, but certainly upper room UVC is very effective because you get the exposure time at removing, at killing the contaminant. And so those type of systems are used quite often. We don't tend to use UVC systems and HVAC systems, even in hospitals, to kill the virus in the airstream. We are doing it to put it onto our cooling coils, and we're doing it to put it onto our drain pans in order to make sure that we kill any contaminants that happen to be on those surfaces, because we get the resident time of the light on those surfaces. So when we want to go induct, as I mentioned before, you know, we got to have minimum UV exposure times of 0.25 seconds. The dosage has to be at 1,500 microwatt seconds per centimeter squared. I mean, there's special things. So, you know, don't think that just because you have a UVC system that was installed to kill any bacteria that's on a drain pan or a cooling coil, that it's going to be killing the SARS-CoV-2 virus if it happens to be floating through the air when it's going by those lights. Most of the time, those systems don't have the UV dosage, and they're running it at not the exposure time in order to be killing it.
Yeah, I've designed a few UVC systems, again, pointing at the chilled water coils typically. And when we were looking at viruses, we were looking at kill rates at about, I want to say right around 40 for a single pass, which is
right.
It's better than nothing. It may be less viral loading, but it's not getting all of them. All right. Okay, another question from Spence. Can computational fluid airflow dynamic modeling help in developing an HVAC design to address the transmission of infectious aerosols?
You broke up a little bit, so okay, I'm reading the question.
Yeah, can CFD modeling help with designing?
Absolutely, it can help. You know, there's a good ASHRAE presentation that was done by Dr. Kankari, who's done a lot of CFD modeling in healthcare applications, and showing the effectiveness of CFD in determining ventilation effectiveness within spaces, not only for healthcare environments, but other types of spaces. And he did some CFD modeling where he actually had someone cough at one location. It was a room with 3 people, and just the difference of putting in 3 return air grills in that space, which is a single return air grill, and not infecting the other people with the fallout from that cough zone. So, I mean, it definitely is a tool that we should be looking at. And there's even some online, I mean, as I said before, you can go to a website, and I'll give a link when I send out the slides for everyone if they're interested, but there is a CFD, a popular CFD, ANCAR does a lot of that stuff. Sorry, I don't want to use commercial names. I shouldn't have done that. But they do have a lot of free stuff related to COVID of assessments that they've done that's interesting for us as engineers to at least come up to speed on.
Great, thank you. And that went right into the next question is, can we get a copy of the presentation? And it sounds like
absolutely. Happy to send that out to you, and you can send it to everyone who's attended.
Thank you. From Vern, and does anyone know how long lived the virus is from time expelled by a human?
How long does a virus live?
Yeah.
There's been several researches on how long the virus lives on certain surfaces. There's not been, I mean, a good rule of thumb that most facilities I've been working in have been using is that the virus, if someone contaminates a space, that the virus will not live more than 48 hours within the space. So you can go in and do your decontamination, you do everything else, but if you just left the space unoccupied, the virus doesn't last more than 48 hours before it dies. And that's whether it's in a fomite form on the surfaces or other things. So my general rule that I've seen by the research has been 48 hours.
Here's a question about fire stairs, generally unventilated. In case of a fire, everyone will follow. Yeah,
not a good situation. I mean, ASHRAE hasn't addressed that specifically with the epidemic task force. You know, hopefully when you're in a building, you're going to have far less occupants. Most facilities I'm dealing with right now are not fully occupied at all. The universities I'm dealing with are mainly running at a 15 to 25% occupancy in their buildings, and it's mainly for things that can't be done remote, like lab type occupancies. And even at the lab occupancies with the social distancing, they're only getting 15 to 25% of the normal occupancy in those spaces. So, you know, I know that ASHRAE, one recommendation ASHRAE does recommend relative to elevators is that people try and take the stairs whenever possible. But my concern with taking stairs is the same thing, is that most fire stairs you go into have little to no ventilation. Some have ventilation, depending on which code you're following, but that ventilation is not going to be near adequate if you have a bunch of people that are hiking up the stairs, you know, 6 or 8 stories. They're definitely breathing a lot by the time they get up in those upper 4 floors. And that concerns me, that there's not a lot of ventilation to remove any aerosol that might be in that type of space.
Yep. Okay, Ken from Reagan Corwin, can you touch on bipolar ionization as a method for helping, 1, have particle virus conglomerate into bigger particles, or 2, by the ability to help inactivate viruses?
I can. I figured that we'd get a question on that because I have clients asking that question. So I'm going to talk a little bit about other air cleaning technologies, and I'm going to kind of follow ASHRAE's guidance on this. I mean, if you take the position documents, the ASHRAE has a good position document. There's not a lot of peer-reviewed research out there showing the effectiveness of any of these, whether we're talking about air ionization, ozone-generating air cleaning devices, or photocatalytic oxidation. There's not a lot of peer-reviewed research. I was able to find a Spanish Ministry of Defense biological laboratory testing that was done in May of this year, showing pretty good results. I got to indicate, though, that the manufacturer actually coordinated the research. The air ionization system reduced bacteriophage MS2 99% after 10 minutes. I don't know how effective that would be at reducing SARS-CoV-2. This is a different type of virus they're actually looking at. And, you know, so I'm unable to find any testing on mitigation of SARS-CoV-2 virus. I kind of put this, you know, in my loading order. You know, if I can't do my ventilation, if I can't get the filtration to MERV 13, or if I didn't have that option, I can't go to 100% outside air, and I can't put in a UVC system to get UVGI, then I might be looking at bipolar ionization. And I do have actually some projects where there are some circumstances where we had some dorm buildings, and it was the only option we really had. We had fan coil units that were serving, you know, 6, 7 dorm rooms, and they needed to do something, and filtration was out of the question on these fan coil units. They only had 1-inch filters, and we went ahead and looked at the research and made a conscious decision with the owner. While we didn't have the you know, studies showing how it's going to reduce the SARS-CoV-2 virus, we felt fairly confident that we could actually get the air ionizers to work to be able to kill the particles and get it into the filters. So, but, you know, I always like to say, go to ASHRAE, see what ASHRAE is saying, and most of this you're going to find what the manufacturers are telling you, but you aren't seeing a lot of peer-reviewed information out there for research on it.
From Vern and please comment on displacement ventilation as compared to mixing ventilation systems.
I mean, displacement ventilation is actually pretty good. There is an article, and it's a research article, and I'm sorry because I read hundreds of these things in the last 3 months alone, but that compares the effectiveness of an overhead mixed VAV system with the effectiveness of a UFAD system, which is more of a displacement type ventilation system. And the UFAD system was effective at everything other than droplets, meaning that any aerosol, it tended to put it into the higher range out of the breathing zone. They said it was better than an overhead mixed VAV system. The only thing is when the droplets got near the floor diffusers, and this is only going to be for UFAD. If you had a displacement system with displacement diffusers down on the you know, wall or something, it'd be different. But they said that it actually resuspended the droplets a little bit more. But overall, that article actually was indicating that UFAD you should not be concerned about.
All right. From Spence Braden, here's a quick clarification. It's my understanding that any UVC system which claims to be effective in HVAC ducts as single pass sterilization design must typically be installed parallel to the airflow and usually be 2 to 5 feet in length. All right.
Yep, has to do with exposure time, has to do with the lighting density or the UV dosage that you're putting. There's a lot of things you need to take into account if you're going to try and do a single pass induct system.
Okay, we've gotten to the end of the questions. If anyone else has anything else and you want to unmute and ask it, you're welcome to. We'll give you a couple minutes and then thank Ken for a great presentation. Is there anyone else who wants a question? I have a quick one for you, Ken, before we get off. I've heard some people talking about putting, both for smoke and for virus that, you can buy a filter from, Home Depot or something and get a MERV 13 or MERV 15 and tape it to your box fan. Have you heard that solution for people and have you seen any effectiveness with that?
Well, I have not heard that solution for dealing with the COVID or the SARS-2 virus, but I have heard that solution for those people that are dealing with the wildfire smoke in their houses, where they're trying to create their own little box fan with a filter to try and at least clean the air and get better air quality. When the AQI in some of these locations, I think I heard Portland was over 450 just last week. So
yeah, we've been up in the 260s or so, 250s around here in Seattle. But
like all of us are engineers, so I mean, if we can get a good filter we trust and we can put it on a fan, we can and tape it, we could probably do a pretty good job at removing contaminants inside the air.
Yeah, I guess the thing with COVID would be that we don't also want to be creating drafts in a space. We would be providing filtered air, but like you said, drafts in where we could be blowing across an infected person. And
if we're in our own homes, I mean, this is where we talk to a lot of clients about even dorm rooms. I mean, if they're going to put 2 people in a dorm room, do I really care about what the filter efficiency is on my fan coil unit if there's 2 people in a dorm room? I don't, because those 2 people are probably going to, if one contracts the virus or contracts COVID-19, the other one's probably going to catch the virus from that other person. It's not going to have anything to do with the HVAC unit having a MERV 13 filter. It's really about multiple zone spaces or other spaces that have a lot more people inside the space where we don't want to do this. Same in our houses. I mean, if there's one person in the house, unless you can isolate them to a single room and they get a bathroom and they're off on a whole other section of the house, it's in those type of circumstances, you might want to build yourself a box fan with a filter in the area that's the clean part. And you might want to put a separate box fan and filter in the room where the person's infected.
One last question here. ASHRAE is encouraging us to increase outside air, but due to wildfires, people have been closing outside air intakes and actually violating ASHRAE 62.1. Any thoughts?
My thought is that we need to be talking to the clients about the importance of maintaining the minimum ventilation. I realize that we have fires, but there's other solutions like, I mean, you could put HEPA filters inside the space, the same thing when you're having wildfires in order to clean the air. You can increase your filtration up to MERV 15 to get better outside air filtration and not get the ash in. So there's a lot of other engineering solutions that don't have the ramifications of potentially causing you to get a community spread event of the virus while you're dealing with the wildfires.
Okay. Well, thanks so much, Kent. Thanks everyone for showing up and hanging out. It was a great presentation. I will follow up. We will be sending out the slides to everyone who registered. If you happen to not be registered and got maybe a link from someone else, you can always reach out to me at ASHRAE, at President of ASHRAE, and I will send you the slides on. So thanks again, Kent. And
Great. Thanks for all the good discussion and the questions. I appreciate it.